Yesterday, we talked about all these angles. And what we said yesterday was you have to know your unit circle for all those values, sine of any angles on the unit circle. Okay, sine, cosine, tangent. So just a quick review. When the question asks for cosine, it's the what value, what coordinate? Cosine is the x. Sine theta is the y. Tangent is y over x. Okay. So and then the reciprocal, you can just reciprocate the numbers yourself. Now, so what we're going to do today is building on top of what we did yesterday, and that is to well, first you have to be ready to use the values, to write down the values of those coordinates. If you use the unit circle method, or if you use my method, you better have the table well memorized so that you can actually get the values quickly. But if you look at here, the angles are a little bit funky. Can you see something special about this angle? It's over 360, right? So now after one rotation, everything resets itself. So we don't need to look at 390. Let's look at something simpler. Let's look at 30. So then this question is basically asking, hey guys, what is cosine of 30 degrees? And just a reminder, cosine is to look at the x value, the x coordinate of the point on the unit circle. Or if you use my table, cosine 30 is with 3 over 2. Okay. And that's really what we are asking you to do. Can you tell us the ratio? And keep this in mind. If we give you the angle, please provide the ratio. If you are given the ratio, you will get the angle. All right, for number 2, it's it's not very pleasant. Okay, so how can we make it a little bit more pleasant? We can make it positive. So negative 225 degrees. Now, one thing I would suggest you do, especially for beginners, especially if you are not very confident, what I would suggest you to do, go ahead, draw the cross, draw a pair of x, draw the x and y axes, and think about what does it look, what does 225 degree, negative 225 degree look like? What does negative 225 degrees look like? Which quadrant would it fall to? Quadrant 2. So it'll be somewhere right here. And this will give you at least some visual confirmation and say, oh, yeah, it's right here. So you are really looking for the normal positive angle, which would be? It gives you confirmation. Okay. Yes, we can get the number, but it's really the confirmation that matters. Okay, so what's sine of 135? Root 2 over 2. Now, at all times, I would say that you should have this either shown on paper or in the back of your mind so that you can cross-check your answers. Like if you say, oh yeah, this is root 2 over 2, just double check to make sure the sign is correct. This is in quadrant 2, it's sine, it's positive, yes, it's good. That's the kind of mistakes that you can totally prevent, okay? This one, again, weird, strange angle because it's kind of big. So a tangent of 17 pi over 6 is the same thing as 5 pi over 6. Just remove the 12 pi over 6 or remove the 2 pi out of the it. So you would say, oh yeah, it's just a tangent of 5 pi over 6. And if you know your values, y over x, or if you know your table, that is negative 1 over square root 3. And then you would need to rationalize it. And that gives you root 3 over 3. All right, I'm going to pause a moment. Any question? Now, this weekend, you really need to practice. You really need to ask yourself, are you ready to recall all those values? One way or the other. If you want to procrastinate until next Monday, I will tell you, you have your stuff, you have other busy stuff to do next Monday. And you don't want to work on this kind of stuff over next Monday or Tuesday. All right, so that's simple stuff. Well, number 4, 5, and 6, they're still simple stuff, but it just looks a little bit more complicated. Now, so you have this. What's the relationship between these two trig functions? What's the relationship between these two trig functions? They are adding, subtracting, multiplying, dividing, and multiplying, right? Now, so we're going to get the ratios. We'll get the y values and x values, and they will multiply together. But before we do that, please do this. Before you rush to get the values, please do this. You will thank yourself for doing this. You will thank yourself for doing this, because once you write down these parentheses, and as you know, I'm very big on notations. And the reason why you want to do that is because I want you to foresee that you may have some negative signs. And if you are lazy, writing down these parentheses, can you guess what could happen? If somehow there's a negative in between, in one of those values, you may think of the multiplication as a subtraction. And that would be tragic. Totally not worth it. So do this all the time, all right? So cosine of 4 pi over 3 is negative 1/2. Sine of 11 pi over 6 is negative 1/2 as well. And then now, by the way, do not get too excited and compute these two numbers. Nope, your job is to fill in the blanks. Finish that job first, one thing at a time. Sine of 4 pi over 3, it's negative root 3 over 2. And cosine of 11 pi over 6 is root 3 over 2. Okay. And now you can go ahead and work on your multiplications. So negative 1/2 times negative 1/2 is 1/4. And then you have a minus because you have a plus and then you have a negative right here. And then root 3 times root 3, it's a 3. 2 times 2, it's a 4. So 1 minus 3, it's negative 2 over 4. So that is negative 1/2. All right, make sure you ask questions. If there's any part that you don't know, make sure you ask. Okay. So parentheses, okay? Parentheses. Anything that you do when you see a bunch of trig functions jamming together, I don't care if they're adding or subtracting or multiplying, writing parentheses will never hurt you. Okay? All right, if there's no question on question 4, let's go to question 5. Any strange thing that you see here? A little 2 right here. What does it mean? Square, right? But now, since you're learning this new, so what I would urge you to do is this. That's what it means. So notation-wise, we will put the square right here. And the real meaning is that the whole thing, cosine of 3 pi over 4, this whole thing being squared. So you are not squaring just the cosine part of this writing. You are not squaring just the angle. You are squaring the whole trig function, cosine of 3 pi over 4, which is equal to negative root 2 over 2. And that should give you an answer of 1/2 because it's 2 over 4. So it's just 1/2. Okay, so notation. We just want to get you more comfortable with the notations. All right, go ahead for number 6. Okay, I think you know how to handle these things. Number 6 is pretty straightforward. So let's go ahead. I give you 2 minutes. Okay, number 6. Parentheses, right? Make sure you do parentheses. Okay, so let's take a look together. So, parentheses, 1 plus parentheses times parentheses. Tangent of pi over 3, you should write down square root 3. Tangent of 3 pi over 4, you should write down negative 1. Any question about these two values? Tangent pi over 3 is, we did it already, root 3. And tangent of 3 pi over 4, it's negative 1. So now we simplify the expression. We have root 3 plus 1, and then 1 minus root 3. Okay. Yay. Are we done? Why not? Yeah, we have to rationalize it. Do you still remember how to rationalize this kind of situation? Multiply what? Conjugates. Anyone wants to know why we multiply by the conjugate? Well, how many of you knows why we multiply by the conjugate? Yeah, so if you don't understand, then you really need to understand. Okay, you may want to write this question somewhere on the paper. Why multiply by the conjugate? First, make sure you learn how to use the word. That's the conjugate, not inverse, not the opposite, not reciprocal. That's a conjugate. 1 minus root 3 and 1 plus root 3, they are conjugates. The second thing is that our job is to not have a square root in the denominator. So we would hope that we can just square everything, but well, you have to make sure that you find a legal way to do it without violating any rules in mathematics. And one thing that we can do is that, wait, hold on. Can we do something like this? Yeah, if you have a plus b times a minus b. That's the whole reason behind the multiplication of conjugates. So if you learned rationalization without knowing the reason why, well, now is your chance. And it could be your final chance to catch on. Because we assume this skill in calculus. Okay, if you talk to your professor and say, I don't know what to do with this, then I'm not sure what the professor will respond to you. Okay, so and this is how, when I learned about rationalization, this gave me some renewed appreciation of a plus b times a minus b. And I was like, oh, I thought it was just all about factoring. it turns out that it can help us get out of this difficult situation. So that's the reason why. And because of that, we will have 1 minus 3 in the denominator because we have 1 squared, which is 1. And then root 3 squared, it's just 3. And then the numerator, you have the 1 plus square root 3 perfect square. So you have 1 plus 2 root 3 plus 3. So you have minus 2 in the denominator. And you have 4 plus 2 root 3 in the denominator, in the numerator, sorry. So let me zoom in a little bit more. So this is what you get after doing the FOIL. They are multiplying. Root 3 plus 1, 1 plus root 3. All right. If you stop right here, what will happen? If you stop right here, what would happen? You have to simplify it. You cannot stop right here. If you stop right here, you would get points taken off because you should know that there are some even numbers waiting for you, some even numbers waiting for you to simplify. And that would be your simplest and final answer right there. Minus 2, minus root 3. So what you see here, the difference between today and yesterday is that yesterday, we'll give you the expectation that, hey, guys, please make sure that you're ready to draw the values from the unit circle, or make sure you know how to read the table that I gave you at the end of the class, and get the values, please. And by the way, let me emphasize this again, that this stuff is not going away. It's not going away after this test. It's not going away after this semester. It's not going away after this course. So if I were you, I would not hate this. I would grow some passion, some affection, some love towards this. Make it happen. Okay? If you hate this, you're gonna get hurt by yourself. So it's not a wise decision if you choose to hate this. Just like when I taught chemistry before, you have to memorize those ions, remember? Polyatomic ions, nitrate, ammonium, acetate, or those phosphates, sulfates. And then people are crying like, oh, what's sulfate? I don't know. And then you have the naming part. And I told the kids, I said, please don't hate them. You're going to use them. Learn to love them. And you will be amazed how much your brain will work when you say, oh, yeah, I love this. And by just saying that you love it, it helps a lot too. Okay, number 7, cosine 2 theta. What's cosine 2 theta? What's the meaning of 2 theta? 2 times theta. All right, so what's 2 times theta? Now, if you say a 10 power over 8, I would suggest you to do the following. Learn how to simplify before multiply. Make this a habit, because if you simplify before you multiply, it actually makes your life a lot easier. Because after you simplify it, you may need to multiply at all. In this case, you just have 5 pi over 4. But if you bring a number larger, you make a number larger and then try to reduce it, that's just more work, more thinking, making your job 10 times harder, which is not what we want, right? We want things to be easier, not harder. So always simplify before you multiply, all right? And cosine of 5 pi over 4, just like the questions from yesterday, it is negative root 2 over 2. Tangent of 2 pi, tangent of 2 theta. Tangent of 2 theta is tangent of 2 times negative pi over 8, which becomes tangent of negative pi over 4. Now, there are a couple of ways you can do this. You could, just like what we did earlier, you can change this to a positive angle. You can do that. Ooh, be careful. All right. You can change it to positive angle. Or if you can imagine where this angle is, what quadrant is this? Negative pi over 4. What quadrant? 4, right? Do you know the location? If you know the location, you know the coordinates, just go ahead, get the coordinates and do y over x. Which will be -1. Okay. Now, I must say one thing though. I'm going to ask a question. I'm going to ask, hey guys, where's this negative come from? Where does this negative come from? Yeah, the sign. Where does this come from? Now I hope you would tell me that, oh, it's because it's in quadrant 4. That's why it's negative, because the y value is negative, right? Or if you say, oh, you can say, oh, this ASTC is in quadrant 4, so only cosine is positive, so tangent is negative. What I would worry is that if you have no idea where this negative comes from, and somehow you scramble and say, oh, this negative, is it from here, from the negative pi over 4, then I would just crush my head to the wall and just think about what happened. What happened? Okay, it's because it's in quadrant 4. Things do appear for a reason. Things don't just pop up. Okay. All right, the last question on this page. Now, so you're given the ratio. We want you to find the angle. And before we start finding the angle, I want you to either highlight or circle something. What does it mean? There are a couple of meanings right here. First, the angle must be within 1 revolution from 0 to 2 pi. That's obvious. And the other meaning is that your angle theta must be in radians. Do not give the angle in degrees. This is the, you can say, cryptic message. Well, if we say it's from 0 to 2 pi, then we expect everybody to know that, hey, we are talking about radians. So what's going on here? It says sine squared theta, it's 1/2. Sine squared theta, it's 1/2. So that means sine theta squared, it's 1/2. Okay, again, just make sure you understand the notation. So I'm writing this just because you are new to this notation. I want to make sure that you don't get confused by this notation. Later on, you can skip this step. But for the moment, I'm going to show it to you. Well, to find theta, what do you need to do? Get rid of the square, and then get rid of the sign. So let's get rid of the square first by square root. But if you do this, I would take 2 points off, because it's a positive and negative square root. Why? Why would it be positive and negative square root? Yeah, if you square negative, it's still positive, right? It's just like asking the question, hey guys, x squared is equal to 9. What is x? It'll be 3 or -3, right? And we say or because we don't know if it's +3 or -3. So we must include both situations. Okay, we take both situations into account. Same deal right here. We don't know what sine theta really is. Positive, could be, negative, well, who knows? So now let's go ahead and split this into two situations. So we have sine theta equals to 1 over root 2 and sine theta over 1 negative 1 over root 2. Okay, the positive version and the negative version. And let's take care of each version individually. So we have, well, we don't really get used to looking at 1 over root 2. Let's go ahead and change it back to root 2 over 2. Okay, so we rationalize it. So this is basically asking the question, hey guys, the ratio, or the y value. What's the y value? Root 2 over 2. What's the angle? We say, oh yeah, root 2 over 2, it's going to be pi over 4 in quadrant 1 and 3 pi over 4 in quadrant 2. Those two angles would get you the y value of root 2 over 2. Okay, or if you use my method, root 2 over 2 means the reference angle is pi over 4. It's positive, though, so that means it must be in quadrant 1 and quadrants 2. So you just get those two angles. And the same line of questioning, same line of thought process. On the right-hand side, sine theta, it's equal to negative 1 over root 2. That means sine theta, it's equal to negative root 2 over 2. And that means theta, it's equal to the angle that gives you the y value of negative root 2 over 2. Which is 5 pi over 4 and 7 pi over 4. Now, there comes a question. The question is, some students would try to simplify the whole thought process, but somehow they simplify it in a not so proper way. They would try to say, hey, Mr. Chen, got a question for you. So do we always have 4 answers for these for this type of question? No, I would say for this question, yeah, 4 answers. But I would tell you that the number of answers is not really what you want to focus on. What you want to focus on is that do you understand how to interpret the notation? And that's why since day 1, I've been telling you, please follow your notation. Please write your notations well. Please do better handwriting, because all these things will ultimately help you. If you don't do it, you get hurt. And I don't want you to get hurt. I don't want any one of my students to get hurt. So, so please follow the notations. Okay. Now, when you get your hand out, I would like you to go ahead, get started, and work on question 14, 16, and 18. 14, 16, and 18. Okay. 14, 16, and 18. All right, so let's take a look at question 14 together. And again, I'm trying to show you some good notations. So before we start, let's go ahead and write some parentheses, okay? And if you want to do it right below it, that's okay too. I would actually encourage you to do it right below it so that you know where they are, what values they are, so you can match them very well. So cosine of 2 pi over 3, it's equal to negative 1/2. Cosine of 11 pi over 6 is equal to root 3 over 2. Sine of 2 pi over 3, it's equal to root 3 over 2. And sine of 11 pi over 6, it's equal to negative 1/2. And that gives you root 3 over 4 plus, negative root 3 over 4 plus root 3 over 4. And that's how we get 0. Okay? So it's just about getting values. It's just about getting the stuff from yesterday. And we just kind of put this together. And once you put them together, it's just middle school math, doing fractions, multiplication. Okay. Number 16. Ooh, number 16 is a bit complicated. So for question 16, you again, you would do this. Okay, you would do this. What is tangent of pi over 6? 1/√3. Tangent of 7 pi over 4? -1. And then we have the same number here. Okay, so so just try your best to simplify this at the moment. 1/√3 plus 1, and then 1 minus 1/√3. Oh, 1/√3, yes. Okay. Now, what do? You can do conjugates, or I think that's one situation you want to take care of first. Do you really like complex fractions? And remember, we saw something like this earlier in the semester. We're like, hey, you like complex fractions? And you're like, no. Then what do? Well, rationalize this to get rid of the square root. It doesn't get rid of the fractions. Well, what makes a complex fraction is the denominator. Let's get rid of the denominator first. So you distribute. So therefore you have 1 plus √3, and then you have √3 minus 1. Make your life easier before you rationalize it. You don't want to rationalize when you have a fraction within a fraction. That's just disgusting, terrible. Okay, troublesome. And now you can have an easier time to do your rationalization by doing the conjugate, just like the previous one. So 3 minus 1, and then you have 1 plus 2√3 plus 3. So you have 4 plus 2√3, which gives you 2 plus √3. Okay. So yes, you will actually see this kind of situation since we have so many fractions with all those ratios. You should anticipate complex fractions. And you should always ask yourself, what do you do when you see complex fractions? Do you like complex fractions? You don't. I don't. So what's your way? What's the suggestion to get you out of this bind? Just multiply by the denominator. Okay. All right. Number 18. Did you do it yet? Number 18? What's your answer? 1, right? So again, I would do this. Okay. So before I do anything with the values, I would just take care of my notations first. I acknowledge that it is the entire trig functions being squared. And then we say, all right, what's cosine of 7 pi over 6? Okay, 6, sorry. 6, and then we have sine of 7 pi over 6, and then both squared. So cosine of 7 pi over 6 is √3/2. And then you have negative, sorry, negative √3/2. And then sine of 7 pi over 6 is negative 1/2. And then square that. So you have 3/4 plus 1/4, which is 4/4, which is equal to 1. Okay. So again, just being diligent. So that's your goal this weekend. Okay. Finish the worksheet from yesterday and today. And well, finishing is not the big problem. The big problem, the big challenge is that do you get the point of doing all these? Do you understand your requirements, your threshold that you have to meet? And that is being able to get these values quickly and accurately. Again, try to push yourself to get these values within 5 seconds. Okay, 5 seconds. And we are just doing sine, cosine, tangents. We are not even doing secant and cosecant. So try to do that. Okay.